Hello everybody and welcome to 3.3 Exploration. So our essential question for this section is how can you use a function notation to represent a function? Okay, so you guys are used to seeing like y equals 2x minus 3 or y equals negative x plus 2 or y equals x squared minus 1 or y equals 2x squared minus 3. But do you notice you have f of x, g of x, h of x, j of x? This is exactly the same thing as y. It's just kind of our upscale math language is what I'll call it, okay? But it operates the same way that you guys have always seen, okay? So what we're going to do is we're going to match these functions with their graphs. So when we look at 2x minus 3, what I think we should do is create a chart, an XY chart, okay? And let's just do, how about negative 1, 0, 1, and 2. Let's just try those out, okay? So we have 2 times negative 1 minus 3, so we have negative 2 minus 3, which is negative 5, okay? So then let's try 0. 2 times 0 minus 3, so we have 0 minus 3, which is negative 3. Let's try another one. 2 times 1 minus 3 will be 2 minus 3, which is negative 1. And then we have 2 times 2 minus 3, so 4 minus 3, which is positive 1. Okay, so if I were to graph this, let me erase this real quick. If I were to graph this, I have negative 1. Oops, you know what? I'm going to need more of the negative here. So let's kind of, whoop. All right. So I've got negative 1, 1, 2, 3, 4, 5. There's my red one. Then I have 0, negative 3, 1, negative 1. And then finally I have 2, 1. So I kind of have this linear function, and then it looks like a straight line here. So what matches with that one? It looks like B. Okay? So that's what we're going to do for all of these. So let's make a little table here. And let's use different colors. So let's try negative 1, 0, 1, 2, just to have a couple. Okay? So we have, pretend there's a negative 1 times x, so negative 1 plus 2. Negative 1 times negative 1 is a positive 2 plus 2, which is 4. Then, again, remember, it's like a negative. I can't get in there small enough because my fingers are too big. 1x. But pretend that's like the negative 1 coefficient. So we have negative 1 times x, which is 0, plus 2. 0 plus 2 is 2. Okay, so now we have negative 1 times 1 plus 2. Negative 1 plus 2, which is positive 1. And then let's do negative 1, oopsies, negative 1 times 2 plus 2. Negative 2 plus 2 is 0. Okay, so if I were to graph this, do a little itty bitty graph. Doop. I've got negative 1, 0, 1, 2, 1, 2, 3, 4. All right, so I've got negative 1, negative 4. I'm sorry, negative 1, positive 4 right here. I have 0, comma 2. I've got 1, 1, and 2, 0. So I kind of have a graph that looks like that. Oopsies, I totally missed that one. Do. All right, and that looks like D. All right. Now let's look at these other two. And I'm going to crop my little paper right here real quick. Hold on a second. All right, so let's make our little T-chart. We have X and we have Y. And let's try -1, 0, 1, 2. Just random values that I use, okay? So remember, when you evaluate expressions, that's in a parentheses. So you've got -1 squared minus 1. -1 times -1 is a positive 1. Minus 1 is 0. Okay? So now we have 0 squared minus 1. 0 times 0 is 0. Minus 1. -1. Now we have 1 squared minus 1. 1 minus 1 is 0. And then let's try a 2. We have 2 squared minus 1. 2 times 2 is 4 minus 1, which is 3. Okay? So now if we were to graph this, let me erase right here. And I've got a little do-do-do. Okay. So we have, oops, I forgot my little tick marks. Oh no. 1, 2, 1, 2, 1, 2, 3, 2. Okay. All right. So we've got -1, 0, 0, -1, 1, 0, 2, 3, and I bet, let's just try a -2 real quick so we can get that value in here. So if we do -2 squared minus 1, -2 times -2 is a positive 4 minus 1, which is 3. Aha! Looky there. This is called a parabola. We're going to work a lot of this towards the end of Algebra 1. And it actually looks like this. Okay? So we used B, we used D, so therefore this one would be C. Okay? Alrighty, so let's go to the second part, evaluating a function. We are going to work together and considering this function, which is f of x, remember that's just a y, okay, y, is -x plus 3. I could rewrite this as -1x plus 3, which equals f of x. Okay, so, we're going to locate the points f of x on the graph. So do you remember what I told you? I just told you this, that f of x also means y. So we're actually looking for x, y on the graph, okay? So just make sure you remember f of x is the same exact thing as y, okay? So let's go find these points on the graph. We're going to explain how we found each point. -1, f of -1. So what I would say, I would write this out. This means is if x is equal to -1, we're going to find the value of y at -1, okay? So you go to your graph and you say, okay, well, x -1 is right here. What is your y value? Well, that's up there, right? Your y value looks like, if I follow, maybe 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4. 4, because it's right here, okay? So this would be -1, comma 4 would be our point, okay? So let me go a little bit slower for the next one. I'm going to use a different color. We have 0, f of 0. So what we're going to do is put this in words. X equals 0, so what is y at when x is 0, okay? So, and this should be x is equal to -1. Sorry, I forgot that. Let me erase this. Oopsies. Okay. All right. So we are going to go to x is 0, which is right here, and we're going to go all the way up till we find our y, which looks like 3. So this would be 0, comma 3. Okay, so again, we're going to write this out in words. X is going to be equal to 1, so what is y at x equals 1? So we're going to go to x equals 1, and we're going to go find our y value, which looks like it's at 2. Right here. Oops, again, sorry, I'm on my iPad. Okay, so when x is 1, look up to the graph, and it looks like y is 2. So therefore, a point would be 1, comma 2. So 2 f of 2. So when x is equal to 2, y is what? At x equals 2. So you're going to go to x is 2. What is y? It looks like, so here's 2. And what's our y value? So look at the graph. It looks like positive 1. So this would be 2 comma 1. Okay? This comes back when you're in pre-calculus and algebra 2. This little concept right here of looking at a graph and evaluating what the function value is comes back in algebra 2 and pre-calculus. Okay? So did we do everything on that? Let me make sure we wrote all the directions and yep. So we did, right? So that's our explanation, okay? Our explanation was we went to go look at x is negative 1 and we went to go look at the y value, okay? So we looked at the x value to find the y value. Okay. Alrighty, so how can you use function notation to represent a function? How are the standard notation and function notation similar? How are they different? So let's think about the first question. How can you use function notation to represent a function? Okay. Well, I'm going to go ahead and tell you because I don't know if you learned this in previous years of math. So if we have f of x equals 2x plus 5, anything we put into x also gets affected to this one. So for example, if I have f of, let's say 3, then wherever that x is, we're going to put a 3. Okay, so let's try another one. F of, say, negative 10. So if we do f of negative 10, then that means negative 10 is going to go in for x. Okay, so that's how we use function notation to represent a function. Okay, it's basically whatever you put in, whatever you input, you will have an output. Now, how are standard notation and function notation similar? Well, because y and f of x are the same exact thing. Okay, this will get y, so y equals, if we did 2 times 3 plus 5, wouldn't we get the same answer? Y equals 6 plus 5, which is 11. And this is also 11. Okay? How are they different? Well, the function notation means you're putting in an input to get the output. Where, so it could be that you do like f of a square equals 2 times a square plus 5. Okay? Where your standard notation is kind of the same thing, but not really, you know? So it's kind of complicated, and you'll have to marinate on this for a little bit, but the more we practice, the better you'll get, okay? All right, so let's go to note taking. In your own words, write the meaning of each vocabulary term, and we have function notation. So remember, our function notation is this f of x thing, okay? So function notation, we could say it represents us putting an x value into output a y value. Okay? So that's all it is. It's a representation that shows the reader we are putting in an x value and we're getting out a y value. Oh, that's it. Okay, well that was short and sweet. So if this is still a little confusing, guys, go watch the videos. I have a couple on my website that kind of go further into explanation of the function notation. We're also going to practice this tomorrow in class. All right, so I'll see you later.